Hello, grade 7. Our lesson today is about change of state. Change of state, thermal energy and change of state. In the previous chapter, you have learned that when you add thermal energy to a substance, the particles either move faster or get farther apart or both. If enough thermal energy is added or removed, what happens? Consider a beaker of water that is heated by a flame as shown in document 1. The particles in ice are close together and cannot move freely. When heated, the particles move faster and further apart. Ice becomes liquid water. When liquid water is heated, the particles are apart and move very quickly and randomly. Liquid water changes to water vapor or steam. The solid is rigid because the particles are close together and cannot move freely. The thermal energy released from the flame affects the motion of the ice particles. The particles in the solid move faster when the thermal energy increases. If the particles in the solid state move fast enough, the solid state changes to liquid state. If the thermal energy increases enough, the liquid state changes to gaseous state. Solidification and melting, or fusion. Fusion. Now consider a crushed ice in a test tube and a thermometer placed inside the test tube. Heat gently the beaker. The thermometer readings for every 2 minutes are recorded till the temperature rises a few degrees above 0 degrees Celsius. The table below shows the variation of temperature during time. During the first 4 minutes, water is in its solid state. After 12 minutes, water is in its liquid state. Melting is the change of state between 6 and 10 minutes. The value of the temperature during this change of state is 0 degrees Celsius. It is constant. Ice gains heat. Melting or fusion is the change of state from solid to liquid. It takes place at constant temperature. This graph shows the variation of temperature in degrees Celsius as a function of time, using the values given in the previous table. As you can see, from 0 to 6 minutes, water is in its solid state. From 6 to 10 minutes, ice is melting at 0 degrees Celsius. Water is in both states, solid and liquid. After 10 minutes, water is in its liquid state. Solidification. Consider a test tube with clean water and a thermometer placed in the test tube as shown in document 3. The test tube is placed in a freezing mixture bath. While stirring water slightly and carefully, the thermometer readings for every 2 minutes are recorded till the temperature falls a few degrees below 0 degrees Celsius. The table below shows the variation of temperature during time. During the first 4 minutes, water is in its liquid state. After 12 minutes, water is in its solid state. Solidification is the change of state between 6 and 10 minutes. The value of the temperature during this change of state is 0 degrees Celsius. It is constant. Water loses heat. Solidification is the change of state from liquid to solid. It takes place at constant temperature. This graph shows the variation of temperature in degrees Celsius as a function of time, using the values given in the previous table. As you can see, between 0 minutes and 6 minutes, temperature decreases to reach a value of 0 degrees Celsius. Between 0 and 6 minutes, water exists in the liquid state. Between 6 and 10 minutes, the temperature is 0 degrees Celsius and solidification occurs. Water exists in both states, solid and liquid states. After 10 minutes, the temperature keeps on decreasing and water only exists in the solid state. Boiling and condensation. Boiling is a change of state of matter from liquid to gas. Heat a certain amount of water. Its temperature during a certain time is measured successively as shown in document 5. After a certain time, the water gets hot enough and bubbles of gas begin to form within the water itself and move up at the surface. Before 6 minutes, water is in its liquid state. The formation of bubbles of gas means that a change of state happens. Water turns into steam. The temperature is 100 degrees Celsius during this change of state. It is constant. Pay attention. Main differences between boiling and evaporation exist. Boiling is the changing of a substance from liquid state to gaseous state with the presence of bubbles. Evaporation is the changing of a substance from liquid state to gaseous state without the presence of bubbles. Boiling occurs throughout the liquid, while evaporation occurs at the exposed surface of the liquid. Boiling is fast, while evaporation is slow. Boiling takes place at a certain temperature. Evaporation takes place at any temperature. Condensation. Condensation is the change of state of matter from gas to liquid. Now observe document 6 and think about the existence of droplets of water on the outside of the bottle filled with cold liquid. The droplets on the water bottle came from water vapor in the air. The change of state that occurred is from the gaseous state to the liquid state. This change of state is condensation. The amount of water vapor present in the atmosphere is usually expressed as the relative humidity. Another activity explains the change of state from gaseous to liquid. Let us take a kettle full of water, heated at a high temperature so that water boils and forms vapor. The process of changing of water into water vapor is evaporation. Hold a cold plate above the spout of the kettle. The steam leaving the spout will conduce at the lower surface of the plate. Incline the plate so that condensed water falls into another beaker kept below. The process of changing of water vapor into water is condensation. Condensation is the change of state from vapor to liquid. It takes place when the vapor is in contact with a cold surface. Conclusion. Matter can change from one state to another if heated or cooled. Examples of such changes are solidification, when liquid changes to solid by releasing heat at constant temperature. Example, water changes into ice at 0 degrees Celsius. Melting, solid changes to liquid by absorbing heat at constant temperature. Example, ice changes into water at 0 degrees Celsius. Boiling, when liquid changes to a vapor state by absorbing heat at constant temperature. Water changes to steam at 100 degrees Celsius. Condensation is when vapor changes into liquid state. When solids gain heat, they melt and become liquids. When liquids gain heat, they vaporize and become gases. When gases lose heat, they condense and become liquids. When liquids lose heat, they solidify and become solids. Variations during the change of state. Consider in document 9 a beaker of water before freezing and the same beaker after freezing. The change of state that occurs in this document is solidification. The volume of water before freezing is 130 milliliters. The volume of water after freezing is 150 milliliters. The volume of water increases while freezing. Note that the volume of a substance decreases during solidification, while the volume of water increases. Therefore, in general, the volume changes during solidification and during melting as well. Pressure and the variation of the boiling point. The figures of document 10 represent the boiling of water in a container in different situations. Complete the following table indicating for each figure the pressure and the corresponding boiling point. At sea level, the pressure is 1 bar, the boiling point is 100 degrees Celsius. In a pressure cooker, the pressure is 2 bars and the boiling point is 120 degrees Celsius. At the top of Mont Blanc mountain, the pressure is 0.5 bar and the boiling point is 80 degrees Celsius. We notice that when the pressure increases from 1 to 2 bars, the boiling point also increases from 100 to 120 degrees Celsius. We notice also that when the pressure decreases from 2 to half a bar, the boiling point decreases as well. The boiling point of water increases as pressure increases, and vice versa. Change of state of a matter is accompanied by a change in its volume. The boiling point of a matter increases as the pressure increases, and vice versa. That's it for now. Thank you for watching.